Hello everyone and welcome to Kiru's online lectures. I am Kira Chamtani and today's topic is hydrocarbons part 3. In part 1 we studied the introduction and about alkanes. In part 2 we studied about alkenes. Now in part 3 we are going to start with alkynes. So coming on to what are alkynes? So unsaturated hydrocarbons which have triple bond like this, these are known as alkynes. Their general formula is CnH2n-2. Since as we can see over here, this is one sigma bond and this is another sigma bond. So one carbon has two sigma bonds, therefore the hybridization is sp hybridization. Alkynes, they show chain, position and functional isomerism. Coming on to nomenclature of alkynes. Now let us suppose if we are provided by like this CH triple bond CH, this is one carbon and this is second carbon. So its IUPAC name will be ethyne, because for two carbon word eth is used, and since there is a triple bond, so the suffix "-ine" will be used. Similarly, the next structure is CH3 C triple bond CH. Again here 1, 2, 3, 3 carbons are there, so its name will be propyne. Then next CH3 CH2 C triple bond CH, 1, 2, 3, 4 carbons are there, therefore its name is butane. Then again CH3 C triple bond C CH3, 1, 2, 3, 4, again 4 carbons are there, but this triple bond is on the second carbon, so therefore its name will be butene. So this is how nomenclature of alkynes is done. Coming on to now preparation of alkynes, how to prepare alkynes. So the first method for preparation of alkynes is from vicinal dihalides. So vicinal dihalides are the halides in which bromine group, that is the halogen groups, are attached to two different carbon atoms that we already discussed in alkenes. So CH2Br, this is vicinal dihalides. So when alkynes are prepared by vicinal dihalides, so here we perform dehydrohalogenation. Dehydrohalogenation means removal of hydrogen and halogen using alcoholic KOH. So we are using over here alcoholic KOH and then we will heat it. So this KBr will be removed and H and OH will be removed. Similarly from here H and OH. So we will take 2 moles of KOH. So KBr and H2O will be removed. We will be left with CH triple bond CH. Thus this is how alkynes are prepared from vicinal dihalides. The next preparation is by the action of water on calcium carbide. So this calcium carbide reacts with water, it forms CaOH whole twice plus C2H2 and this is ethyne. So this ethyne is prepared on large scale by the reaction of water on calcium carbide. And calcium carbide, how it is produced? So when we heat quicklime with coke, we get calcium carbide plus CO. Next preparation is from tetrahalides. So from tetrahalides, alkynes can be prepared by the action of zinc. So this is a tetrahalide like CHBr2, again CHBr2. So here what will happen, we can see over here, these halogen groups will be removed and we will get CH triple bond CH. So we have to remove halogen groups from here, therefore this reaction is known as dehalogenation because halogen groups are removed from here. So, in dehalogenation of tetrahalides, we take zinc, and thus zinc bromide is formed as a byproduct. So, this is how alkynes are prepared from tetrahalides. Next is by electrolysis of potassium salt of fumaric acid. Now, this electrolysis we have already studied in alkanes. So, now we will be taking fumaric acid. So, fumaric acid is CHCOOK double bond CHCOOK. This is fumaric acid, and on electrolysis of this fumaric acid we will get alkynes. So, the same method is followed over here. This H2 will be removed, KOH and KOH will be removed, and CO2 and CO2. So, we will get on electrolysis we will get alkyne, that is if we are taking potassium salt of fumaric acid. So, we will get ethyne plus KOH plus hydrogen plus oxygen. Next method is formation of alkynes from carbon and hydrogen. So, acetylene, they can be prepared by passing a stream of hydrogen through electric arc, that is carbon and hydrogen with electric arc at the temperature of 3270 Kelvin, we get acetylene. Coming on to next preparation, which is by the action of silver on chloroform or iodoform. So, here we will take chloroform or iodoform, like I have taken CHI3 plus silver is acted on it, Ag. Now, we will take 2 moles of silver, we will take 2 moles of iodoform over here. So, we will write like this I3 and CH. So, this I3 and Ag will be removed, we will take 6 moles of Ag. So, we will get over here CH triple bond CH plus 6 AgI. So, this is how we prepare alkynes by the action of silver on chloroform or iodoform. Now, coming on to the physical properties of alkynes. The physical state, if we talk about, the first 3 alkynes are gases, while those from 5 to 13 are liquids, and higher members are solids. Melting and boiling point, as we already know, it increases with increase in molecular mass. Solubility, it is insoluble in water and soluble in organic solvents like benzene, hexane, ether, carbon tetrachloride, etc. Density, alkynes are lighter than water, and yes, their density increases regularly with increase in molecular mass. Now, coming on to the chemical properties of alkynes. So, the first chemical properties of alkynes is acidic character of alkynes. So, if we see over here, the terminal alkynes, they behave as a very weak acids, and therefore, these terminal alkynes, they react with strong bases like NaNH2. So, this CH triple bond CH, it is a terminal alkyne. Since it behaves as a very weak acid, it will react with NaNH2. So, what will happen? This H will combine with NH2 and we will get over here CH triple bond CNA, and this CH triple bond CNA is known as monosodium ethynite plus ammonia is formed over here. So, this reaction is basically shown by terminal alkynes only, because these terminal alkynes, they behave as acidic in nature. Similarly, this alkynes, like we reacted it with NaNH2, it also reacts with sodium. The product's formation will be same, which is CH triple bond CNA only. Here hydrogen will be replaced, and thus we will get half of H2. So, we can see over here the terminal alkynes are basically showing these reactions because terminal alkynes are acidic in nature. and this acidic character of these alkynes, it decreases in the order of, like we have CH triple bond CH. So, this is more acidic as compared to propene as compared to bromine or butene. So, basically acetylene is, as we can say, it is far less acidic than water. But if we talk about alkynes only, so the trend is followed in this order. Thus, we say acetylene is more acidic than propine, and propine is more acidic than butane. So, this was about the acidic character of alkynes. Coming on to addition reaction. So, addition of hydrogen takes place over here, addition of halogens takes place over here. So, we have like alkyne CH triple bond CH. So, if we are adding hydrogen over here, we will get, in presence of catalyst, we will get CH2 double bond CH2. On further adding hydrogen, in presence of catalyst only, we will get alkanes. Thus, if we will take over here Lindlar's catalyst, we will get a cis isomer, cis butene, and if we are adding hydrogen with sodium in liquid ammonia, so we will get trans isomer of it. Now, if we are adding halogens, that is Cl2 in presence of CCl4. So, in both the carbon which are triple bonded carbon, Cl group will be attached over there, and we will get CH Cl double bond CH Cl. This is known as 1,2-dichloroethene. So, this is a reaction when chlorine is added to it. Similarly, if we add HBr, that is bromine, HBr, that is hydrogen bromide, if we are adding over here. So, according to hydrogen bromide, we will get over here CH2 double bond CHBr. On further addition of hydrogen bromide, Markovnich's rule will be applied. Markovnich's rule states negative part goes to the carbon having less number of hydrogen. So, it will be CH3 CH Br Br. The next is HOCl. So, when we are adding here HOCl, again will in one carbon atom there will be attachment of OH group, and in another carbon atom there will be attachment of Cl group. On further adding HOCl, so when further HOCl is added, we will get CH OH, here OH, then CH Cl2. In one carbon, the two alcoholic group are unstable, so this water will be removed. Thus, we will get Cl2CH CHO. This is known as dichloroacetaldehyde. So, when hydrogen is added, that reaction is known as hydrogenation. When Cl2, HBr, HOCl, these are electrophiles. When these reactants are added, these reagents are basically added, it is known as electrophilic addition reaction. Similarly, when nucleophiles are added like water, alcohol, HCN, acetic acid, these reactions are known as nucleophilic addition reaction. So, an addition of water, we will get CH2 double bond CHOH, we will rearrange the bonds over here. So, on rearrangement, we will get CH3CHO. Similarly, if we are adding HCN over here, so we will get CH2 double bond CHCN. So, these reactions, when nucleophiles are added, we call it as nucleophilic addition reaction. Coming on to now the next chemical property of alkyne, which is polymerization. So, in polymerization, first we will study about cyclic polymerization. So, cyclic polymerization, in cyclic polymerization basically what happens when acetylene, this is acetylene, when acetylene is passed through red hot tube or quartz, so it trimerizes to form benzene. So, what happens, these bonds are dispersed in presence of red hot iron tube, we will get benzene. Since over here 3 moles of benzene are combining to form a closed ring like structure, they are forming cyclic structure, therefore it is known as polymerization, cyclic polymerization. But in same case, if we are talking about like linear polymerization, so n moles of CH, n moles of ethyne under suitable conditions, they will yield, so this bond will come here and this will come here, so it will form CH double bond CH, CH double bond CH, and this also N. So, linear polymerization of ethyne under suitable condition yields polyethylene. So, this is about the polymerization reaction of alkynes. Next is oxidation. Now, let us suppose we have over here CH3 C triple bond C CH3. So, on oxidation the different conditions are there. The first is combustion. So, when alkynes are burnt in excess of oxygen, that is when combustion takes place, we get CO2 plus water and large amount of heat is produced. The heat which is produced, it is used for welding purposes. Next is oxidation with KMnO4. So, this ethyne when it is alkyne when passed through the solution of alkaline solution of permanganate, like we have KMnO4. So, here basically if in between, that is if triple bond is not there on the terminal positions, so these triple bonded carbon atoms changes to ketonic group, like it will form CH3 C double bond O, C double bond O, CH3. So, this is the case when alkaline solution of potassium permanganate is taken. In similar reaction, if it would have been a terminal alkyne, so the terminal alkynes, the same conditions results in the formation of acids. So, thus here we will get oxalic acid. The third reaction under oxidation is combustion, ozonolysis. Ozonolysis is basically first it is treated with ozone and then the cleavage takes place with the help of zinc. So, if again this is also same, if triple bond is in the middle position, the triple bonded carbon gets converted into a ketonic group. So, here we will get CH3 C double bond O, C double bond O, CH3. But if terminal alkynes are there like CH3 C triple bond H, so the terminal group on ozonolysis gets converted into aldehyde group. So, thus here we will get CH3 C double bond O H, that is if terminal alkynes are there, we are going to get aldehydic group. So, this was all about the chemical properties of alkynes. So, in today's video we studied about alkynes, how to prepare alkynes, their physical and chemical properties. Hope you guys are finding videos helpful. So, do like, share and subscribe the channel. Thank you.